Okay, we're going to talk about acids and bases, strong acids, strong bases, their strength, and pH here. So let's first start talking about what is a strong acid and a strong base. Well, there's really no rules in saying for acids which, these are strong because you just have to memorize this list of seven. Okay, and it's HCl, HBr, and HI. Now, what those have in common is they're in the halogen group on the periodic table, the next to the last column. Okay, and they're on top of each other, Cl, Br, and I. Okay, and then you have H2SO4, HNO3, and HClO3. Now, those are all polyatomic ions. And what those three have in common is if you'll look at the ratio of hydrogens to oxygens, there's exactly two more oxygens than there are hydrogens. And the last one is the exception to any rule, and that's HClO4. Okay, so if you're ever asked on a test to name seven strong acids, then you're going to have to memorize this list because you're going to have to write those seven. But sometimes on a test they give you four acids and they say which one of these four is a strong acid, and you'll just have to make sure that you are able to recognize and pick that out. All right, so strong bases. And this is a little bit easier than acids. A strong base is any element from group 1 on the periodic table, so that's that first column, combined with OH, the hydroxide ion. Okay, so if we look at that first column on the periodic table, there's lithium, sodium, potassium, rubidium, cesium, and francium. And any of those combined with the OH ion makes a strong base. All right, now let's look at foods and things that we eat, or bloods on one of these. Of course, we don't eat blood, but let's look at some common things, and let's talk about pH. Well, pH is a linear range from 0 to 14, and exactly in the middle is 7, so that's considered neutral. So anything from 0 to 6.9 is going to be considered an acid, and 7.1 to 14 is going to be considered a base. And the midpoint starts at 7, and as it goes toward 14, it gets stronger and stronger and stronger base. And as it goes toward 0, it gets stronger and stronger and stronger acid. Okay, so let's look at some foods. Apples, asparagus. Apples 3.3 pH. Asparagus is 6.5, bananas 5.0, blueberries, cantaloupe, celery, cherries, ketchup, all of these have a pH of less than 7, so they're considered acids. And most of the things that we eat or drink are acidic. And I could only find a few things that were actually basic. Tofu, 7.2, and tea is 7.2, so it's just very slightly a base. I mean, just barely a base. Frozen cooked corn is 7.5. Human blood is 7.4. Baking soda. Sometimes we use baking soda in cooking, especially in cookies. That's 8.3. And then we get into things like your antacids, things that when you have a upset stomach or you have too much acid and you have like indigestion, things that that's why these things are basic, because you have stomach acid, and sometimes that stomach acid, you get too much of it, it kind of indigestion, it kind of refluxes up into your esophagus. So we use bases to neutralize that acid. So milk of magnesia is 10.5. And your stomach acid is hydrochloric acid. It's pretty strong acid. We're talking down around, 1 pH. So we have to have a pretty strong base to counteract that. So milk of magnesia is 10.5. Now, of course, we're not going to drink ammonia. Ammonia is a cleaner, and that's 11.0. That's a little bit too strong of a base. And then, of course, we have drain cleaner is your strongest base. Drain cleaner is made with sodium hydroxide, and that's pH 14. That's your strongest base, and drain cleaner is pretty powerful stuff. It can kill you if you actually consume it, drink it. So let's not do that. All right, so moving on. The pH scale, when you look at your formula chart that you get to use on tests and things, you're going to see that the formula for pH is on this page. It's given to you, and I've circled it in red there. Okay, so if you're looking for that formula when you're taking a test, just make sure that you know it's on here. It's on this chart, and it's on this page. So, you know, your formula chart is 4 pages. So it's on this page where solutions are, and here's your formula. We're going to talk about using the formula for pH here. So pH, the formula for pH is the negative log of the hydrogen ion concentration. So when you see the bracket, this square bracket, and you have a hydrogen ion in that bracket means the concentration of. Okay, and that's in molarity, so that's a capital M. If you think back to our last unit, we're talking about molarity. The unit for molarity is the capital M. So if you know the concentration of the hydrogen ion, then you can plug it into this formula and you can calculate what the pH is. Okay, now on the other hand, if you don't know the concentration but you do know the pH, then we can rearrange this formula to get this formula, and then we can plug in the pH to find the hydrogen ion concentration. Okay, and 14 minus the pH is equal to POH. So POH plus the pH, we're going to see this in just a minute, they all equal 14. So you have a homework chart that starts out, it looks like this. There's a lot of empty squares, but some of the squares are filled in. And then you have to use formulas to calculate everything. So let's look at the top line of that homework sheet. You're given the pH of 3.78, and it asks you to find the hydrogen ion concentration. Okay, so we know the pH. We're looking for hydrogen ion concentration. So think about GSP. You're given pH, the G. You're solving for the hydrogen ion concentration. Okay, so what formula are you going to use? The P. What's your plan? Well, if you think back to this slide, rearranging the formula that we're given gives us the hydrogen ion concentration is equal to 10 to the negative pH. Okay, so if we take 10 and the negative pH, if we raise it to the power of the negative pH, it's going to give us 1.66 times 10 to the negative 4th molarity. So that's the answer there. Okay, now we're looking for POH. Well, we know pH, so we can figure out the POH, because remember, pH plus the POH are equal to 14. So if we rearrange that, we're solving for POH. POH is equal to 14 minus the pH. Okay, and the pH is 3.78, so when we subtract that, we get 10.22. Okay, now we need to find the OH concentration. Well, that same formula that we used for pH, pH is equal to the negative log of the hydrogen ion concentration. We can just substitute OH here for H. So POH is equal to the negative log of the OH concentration. And we can rearrange it and substitute in OH for here as well. So the OH concentration is equal to 10 to the negative POH. Now, please use your negative here. It's the negative to the power of the negative pH or POH. I had some students that were forgetting this negative sign here and getting wrong answers. Okay, so 10 to the negative POH. Okay, your POH is 10.22, so it's 10 raised to the power of negative 10.22. So we get the answer of 6.02 times 10 to the negative 11 molarity. Okay, now finally, we need to say if it's an acid or a base. What you're going to do is refer back to the pH. to tell if it's an acid or base. Remember, if it's under 7, less than 7, then it's an acid. Okay, so we put acid there. Okay, let's look down at the second row. Well, on the second row, we're not given the pH, we're given the hydrogen ion concentration. Okay, so we're trying to solve for the pH. So let's look at an equation solving for pH. That's going to be our original equation that you're given on your formula chart. pH is equal to the negative log of the hydrogen ion concentration. Okay, so we're going to substitute in this number, 3.89 times 10 to the negative 4, in, because that's the hydrogen ion concentration, in that equation. So we're going to get the negative log of 3.89 times 10 to the negative 4. Okay, and when we do that, that's going to give us 3.41 as our pH. So we put 3.41 right there. Okay, now again, now that we have our pH, we can do the math and subtract and get 10.59 as our pOH. It's 14 minus 3.41. Okay. Now to get the OH concentration, it's going to be 10 to the negative pOH. Right here, OH concentration, 10 to the negative pOH. So instead of 10.22 here, we're going to substitute in negative 10.59. You're going to get a slightly different number. Okay, so just keep in mind that there's 6 equations. Okay. You're given this first equation here, and then rearrange it to get these 2 equations. Now remember, pH, H, pOH, OH. It's the same one, you just substitute in H or OH. Okay, so again, rearrange them, get these 2 equations, and then just know that on the pH scale, it's pH plus pOH equals to 14. So whatever you're looking for, if it's pH here, you're going to take 14, subtract pOH to get that. Okay, so if you know how to rearrange, you're pretty set on this. But if you don't know how to rearrange this equation to get to this equation, well, then you have to memorize them.